Okay, so in this question we're told about alpha, right, or sine alpha is 0.4, right, so we'll use that value now in a moment. But yeah, this system gets released, and you can see from this now, because this is the heavier mass, I'm just thinking now that this will sort of pull, so this will actually slide down the plane, right? I might be wrong, but I think that's what's going to happen here, because it is the heavier mass. So if we put this as our direction of acceleration, okay, and then we're going to, obviously then B is going to get pulled up, so we can have accelerating upwards that way. Now when I resolve at B, it's really easy, isn't it? Okay, so we're using Newton's second law, okay, in the direction of motion. Resolving up B is really easy. So if it's going, when the system gets released, if this is going to go slide down the plane and B is going up, we'll have T, take away 9g equals 2, mass times acceleration, 9 times A. Alright? Now when I resolve at A, it's a different story of course, because remember, we've got to go in the direction of motion, and the direction of motion is going in the direction of that string. Okay, so that's really, really important. And for the direction of the string, I need to have the component of the weight, which is actually pulling it down, but the component in the direction of that string. Okay, so I need to work out what the component is here. And remember, if this is angle alpha here, and if I draw the perpendicular, okay, to the plane, that's going to be alpha there as well, right? That angle there is the same as this angle here, as I explained in the last video. Okay, it's got to be, just the way it works, because this here would be 90 minus alpha, if you think about it, right? I've explained in the last video though. So that means that's got to be alpha. Now if that's alpha there, that means this will be 11g cos alpha, which we don't actually need in this case, and then this will be 11g sine alpha, okay? Alright, and of course you notice here I haven't put the normal reaction in, okay, which is perpendicular to the plane, because I don't need it, right? I'm not resolving perpendicular to the plane, I'm resolving in the direction of motion of that string, okay? So if I look at what I've got here, then I've got 11g sine alpha, take away then the tension, and that will equal mass, which is 11 times A. Okay, so then I can add them, 1 and 2, I call them 1 and 2, I can do 1 add 2, and you know then the t's will cancel, t and minus t disappears, you'll have minus 9g plus 11g sine alpha, and that will be 20a, I add them. Now, you know that sine alpha is 0.4, okay, so quite simply then to get a, you've got to do minus 9 times 9.8, plus then 11 times 9.8 times 0.4, all divided then by 20. Okay, so you can get your acceleration out. And we divide by 20, and I get an answer out, if I've done this right, to be minus 2.254 meters per second squared. Now, I've got that out as a minus, right? Which means I've got my direction wrong, haven't I? That means actually I should have had my acceleration going that way, this way. Okay, so actually when it gets released, B is going to fall down this way, and it's going to pull this up. Now that might surprise you. You might think, well, hang on a minute, this is heavier mass. This is the heavier mass here. This is the lighter mass. Okay, but actually that can happen depending on what this angle is here. This angle is here. This could have more of an effect, yeah, because of the fact that this is on an inclined plane, right? And the weight doesn't have a full effect in that sense, right? Because it's resting on here, isn't it? Okay, and we're only considering the component of the weight parallel to the plane. So I got A out to be negative. Now that doesn't matter, right? It just means I got my direction wrong. So I just need to say, actually, A will be moving with acceleration of 2.254 meters per second squared, and I say up the plane, yeah? Okay, it'll be going up the plane. So you can put it as a positive as long as you clarify then the direction it's going in. And then what I'll do then is if I sub it in 1, so I've got t minus 9g, remember, in 1. So 9 times 9.8 equals then, equals 9. Now remember, these equations are set up for this answer here, so I need to put the negative one in, and then I can get my tension out. to be 67.9 newtons.